Hey everyone, in this lightning talk, I'll be talking about container breakouts. So the title of my talk is Container Breakouts from Zero to Host Compromise. So in this, it's going to be a quick lightning talk where I'll be talking about a few attack scenarios and how do they work when it comes to container breakouts. And then we are finally going to talk about some key takeaways. So introduction, what is container breakout? It's basically an attack where the code inside of a container is able to escape the isolation. As you know, that every container system has, like if you've studied the architecture of Docker, you might know that they have namespace and C group isolation. So it's basically when the code inside of container escapes the isolation and gain access to the host system. That's when we can say that we have container breakout. So why does this matter? It's basically because a container breakout can turn a single container who is compromised into a full host compromise, because you're basically able to access the host which is running the Docker agent. And because these containers basically just share the host kernel, right? So a breakout can potentially lead to root access onto the host. Let's study these attacks. I'm going to talk about three attacks here. The first one is pretty simple. It's about the Docker socket exploitation. So whenever the Docker daemon runs, Docker runs in a client server setup. So whenever Docker runs, there is a daemon socket that is exposed at var run docker sock. And if accidentally this is exposed inside of a container, then you can basically just leverage this socket. This socket is root owned, so you basically have access to the Docker API, server API, and you can just leverage that to launch a new shell. Um, and they can basically just chroot into to get the host shell. So this is how it would look. For example, if you run a container with the entire file system mounted to the slash host domain, slash host folder, you can just basically just like access the socket to this, or just like access the entire file system through this. Second one is privileged container reviews. In this case, if we run a container with the privilege flags, or basically any flags that disables isolation, which it hugely lowers the security, which basically allows the container to get access to all of the kernel capabilities and the device access. So an attacker basically in a privileged container can directly interact with the host. They can do a namespace pivot, or they can do a device mount. So if a container usually shares the if the container shares the host PID namespace, then the attacker can just use the nsenter command to get into the host PID process namespace and get root shell. The second option would be even without like a shared namespace, if the devices are mounted, like for example, if an attacker can see the host disk device like /dev/sta, and if it is mounted inside of a container, then they can chroot into that and navigate the entire host file system, basically achieving the full escape. This is how this would look like. For example, you're inside of the container. I'm able to use fdisk and see that the dev SDA device is mounted. So you can access that through the container and achieve a full breakout. And the third one is just going to be volume mounts. So usually what happens here is you accidentally have unrestricted or sensitive host directories mounted inside of a container. So for example, a container might have the host path like etc, or even the entire file system, as we saw before in the Docker socket exploitation screenshot, where you can just have the entire root file system mounted. So if these are read write, or if the container just runs as roots, then the host just see this risk. For example, if the etc folder is mounted, then attacker can just potentially update the ssh, append a new user to the host file system, or maybe if they can just add an SSH key to the authorized keys, then just simply log in as that user, and just basically misconfigured mounts can result into disastrous things. A few key takeaways that I wanted to share out of this is containers not equal to security boundaries. Just because a container says that it has isolation doesn't mean that it's secure by itself. There are misconfigurations or vulnerabilities that can collapse this isolation within seconds, and always treat them as the same caution as if you are running them on the host. And understand that misconfigurations equal to risk. The common theme is that like convenience features like Docker socket access, privilege mode can introduce huge risk. And continuously test your own containers in safe environment to discover breakout paths. And finally, the call to action is to go back to your container deployments and apply what you learned today. Validate that no sensitive socket or excessive privileges are present, and push for secure defaults in your CI/CD pipelines. Thank you.
Hello everyone, my name is Sandeep Ogety, and today I'll be talking about zero trust architecture in cloud and DevOps environments. So, as we all know, like organizations migrate to cloud native environments and DevOps driven infrastructures, and traditional parameter security is no longer enough. And today I'm going to talk about one thing is like never trust, always verify. So the core principle of zero trust is like simple, never trust, always like verify. It assumes like that every access request could be compromised, whether like coming from like inside or like outside the network. This model is like essential for like distributed cloud environments and also like cloud infrastructures and DevOps workflows, where workflows can like move across like different environments. And also implementing like the zero trust architecture in cloud environments, it's it is a complex process, but I think it's like we have to think about like few things in mind. First, I could tell is identity and access management, which is IAM, and also micro segmentations, which is also like very important, which also plays like very important role in the zero trust architecture for the DevOps, and also continuous monitoring and the data protection. So coming back to the IAM, like we need to have like a strong authentication for the users and also services, enforcing like at least a least privilege model. And also for the micro segmentation, it divides the workflows into like isolated security zones to limit breach impact. And the continuous monitoring, which uses like real-time analytics and AI-driven insights to detect anomalies. And for the data protection, ensuring end-to-end encryption for the data security prevention unauthorized access. And these are like the core components, and also we need it, for implementing the zero trust architecture in the cloud. And coming to the practices, right? I think in cloud native environments, implementing the zero trust requires like policy driven security and also like automation. So for the first, for the cloud native controls, we leverage like built-in security services from AWS, AWS configure, or like we can also leverage the services like from Azure or GCP. And also the API driven policies, like using automation to enforce security at the infrastructure level. And also, of course, like the MFA, the multi-factor authentication, ensuring every access request is like validated. And also other important aspect is like just in time access, which just use like an time bound access, providing like temporary least privilege model access, instead of like static credentials, which is also really essential for the zero trust practices in DevOps. And also on the benefits and challenges of zero trust architecture, right? So in a DevOps driven organization, security must be like embedded into the development pipeline. I think we have to have a lot of security in build, let's say if you're building an application, and deploying towards like until prod. I think at the lower environment, like let's say in the dev itself, you have to enforce the security in the pipelines, having a lot of different third party tools or like inbuilt tools, scanning all the repositories, all the Docker images, or all the application aspects of the repositories, no matter what, which environment it's deploying to. And also let me tell like some workflows in my opinion, which enhances the DevOps workflows, right? So like I was talking before, securing the CI/CD pipelines, like we have to verify at every stage of the development with like automated security checks. And also of course the infrastructure as code, the security aspect of it is to validate the infrastructure configurations before the deployments, just to make sure like we don't have any credentials or anything in the infrastructure as code deployment. And also of course the automated compliance, like enforcing security policies in a real time to meet like compliance standards is also critical. And lastly, I would call out is like this secrets management, which also like is a key aspect of zero trust architecture, like protecting all the credentials like the API keys and also the sensitive data with DevOps pipelines, which also gives like challenges of and also benefits of zero trust architecture. I think when following all these, I think it's gonna benefit the application deployment and also make sure that your pipelines and also that your environment is secure. I think with that said, I think thank you so much for giving the opportunity and speaking about the zero trust architecture. Thank you all.
To deepfake, cybersecurity's new villain. We'll be covering topics such as impact, creation, and detection of deepfakes. Before we jump into the topic, who am I? I'm a software engineer with 7 years of experience building network security products. So, what are deepfakes? Deepfakes are synthetic fake media that impersonates as the original content. The form of media could be anything from audio, images, text, or even a video. The goal for the scammer or attacker is to create a hyper realistic content. Lately, we have seen a rise in these attacks, the most famous one being where an engineering consultancy was duped of $25 million. The Hong Kong based employee received a meeting invite where everyone was generated through deep fakes. The employee was fooled into believing that the fake CFO is real, resulting into a wire transfer of $25 million. The other incident includes that of Edinburgh professor who was scammed into sending Euro 17,000 to a deepfake online girlfriend. A French woman was also scammed into believing she was talking to Brad Pitt and ended up losing 8,050K. DOJ uncovered a Russian operation called Doppelganger, where Russia's deep state was involved into creating misinformation through the use of deep fakes and posting them on various websites. How are deepfakes created? Here, the encoder is a neural network that learns to represent facial features into a latent representation state. The latent representation state is marked in the middle. Think of the latent representation as a condensed vector that is able to capture the most crucial facial features of Alice and Bob. So we use a single encoder to capture the latent representation state for both Alice and Bob. After this, we train two decoders where each decoder is able to take the latent representation and recreate Alice's face, and the second decoder is able to recreate Bob's face. Once the training phase is done, we take the common encoder, input Alice's face, we create the latent representation of Alice's face, and we use Bob's decoder, which is capable of taking input the latent representation state and recreating Bob's face. By using this technique, we are able to recreate the image containing Bob's face using the latent representation of Alice's face. And this causes the face swap. Once this has been done, what we do is we create a hyper realistic image or a video. And in order to do that, we use something called as GAN, which is Generative Adversarial Network. GAN has two competing networks. One is the generator and the other one is the discriminator, quite aptly represented here with Tom and Jerry. So Jerry keeps finding ways to fool Tom and ultimately is able to beat Tom. So here the generator keeps creating, tries to create more and more realistic image and is ultimately able to fool the discriminator, increasing the realisticness of the image itself. So how can deepfakes be detected? From a visual and temporal artifacts point of view, there are two broad categories. One is individual frame, and the other one is the frame to frame transition. In the individual frame category, what you would be noticing with a deepfake content is that where the where the fake where the fake face meets the original frame, you will see some blurriness there, or you would see something like a halo effect around the face. Others are like facial feature misalignment, where if the swap is not proper, you would see some kind of misalignment there. In frame to frame transition, you may see irregular blinking pattern, or you may see inconsistent motion in the video itself. Other ways of detecting deep fake is through biometric and physiological signals, such as the variation in skin color due to blood flow, or even slight micro movements. One of the other things for biometric that could be used is the color of the iris that can be used to detect deep fakes as well. Thank you.